All right, moving right along, we are now on rational and irrational numbers. Learning goals for this lesson include, I can evaluate an expression and determine if the solution is irrational or rational for sums and products of expressions in radical form. Evaluate an expression and determine if the solution is irrational or rational for expressions written as rational exponents. And explain if the sum or product of two irrational numbers can be rational, as well as give an example to support my explanation. So, vocabulary, because you haven't heard much of this before. Irrational numbers is a real number that cannot be expressed as a ratio of integers, or a fraction. Therefore, irrational numbers, when written as decimal numbers, do not terminate and they do not repeat. Rational numbers is a real number that can be written as a simple fraction. Most numbers we use are rational numbers. So, an example of an irrational number is something like this. If you have the square root of 5, we can't write that as a fraction. If we were to actually type that into a calculator, it would be a never-ending decimal that does not repeat. Just because you have a radical does not automatically mean it's an irrational number. So please bear that in mind. That is not automatic. All right, so for the sum of irrational numbers, when you add two irrational numbers, you treat the radical and the number under it as if it were a variable. Meaning if you add or subtract them, that they must be identical. Keep in mind, however, that some radicals can be simplified. So for example, the square root of 3 plus the square root of 5, you can't do anything with it. They're not the same. Okay, the answer would just be square root of 3 plus square root of 5. Square root of 7 plus the square root of 7. Now we have two that are the same. So how many square roots of 7 do we have? 2. So just like with exponents, if we had, or variables, if we had x plus x, it would be 2x. We do the same thing with this. Radical 7 plus radical 7 equals 2 radical 7. So again, there's a 1 out in front of this that we don't write. And then finally, radical 3 plus square root of 27. Square root of 27. Okay, we can break that down. So we have 27. 27 can be rewritten as 3 times 9. 9 can be written as 3 times 3. When you have something like that, that's called simplifying the radical, if there's ways to make this number smaller. So if we have, remember, this is like having a 2 out in front. So any pairs of 3's we can pull out. So that would mean we could pull out one pair of 3's, and that would leave us with this. If we had something like the cube root of, say, 16, that's the same as 4 times 4, which is the same as 2 times 2. Okay, we could pull out 3 2's. Well, when I say we can pull out a group of 3 2's, and we would just put the one number out in front, whatever's left would remain underneath. Okay, so this can be rewritten as that, as I show you here. And now we have similar numbers. We have the same numbers under the exponent. And remember, this is the same as like having a 1 out in front. So we just add the numbers in front, and we get 4 radical 3. Products of irrational numbers. Remember, product is multiplication. So when you multiply two irrational numbers, you multiply any terms outside the radicand, and then multiply any numbers under the radicand. Okay, so it's two separate bits of multiplication sometimes. If possible, you must simplify the number that's under the radicand. Unlike addition, the numbers under the radical do not have to be the same. So, like if I add root 3 times root 5, 3 times 5 is 15. We can't do anything with that, so the answer is root 15. Root 5 times root 5 is the same as root 25. The square root of 25, we do know the answer to, is 5. So there's an example of, we have a number under the radical. It doesn't automatically mean it's an irrational number, because we can find that. And then finally 3 plus, let's make that times. 3 times the square root of 27. This is going to be wrong here. So what that would be, so ignore what's going to come up. This would be 3 square root of 3 times 3 radical 3. So 3 times root 9. Square root of 9 is 3, so 3 times 3. Your answer would be 9. So that's another way that this can work. Or you can just say, well, I don't want to do all that. Let's just do 3 times 27, which gives me the square root of 81, which is also 9. Okay, so either way it works. Yes, this is much easier, but I'm just showing you why that also works. All right, first example, evaluate and determine if the solution is rational or irrational. So we've got root 7 times root 7, which gives us square root of 49. The square root of 49 is 7. 7 is a rational number. There's nothing left underneath the radical, so it is a rational number. Okay, same question, but now we have a square root of 11 plus the square root of 11. So we're adding this time. We have like bases, so we can add them together to get 2 square root of 11, 2 root 11, which is irrational. Because anytime, it doesn't matter if you have something like, if you had 4 plus 2 square root of 11. Yes, this is a rational number, okay, but this is not. And because they are all part of the same expression, the entire expression would be irrational. So just bear that in mind. Okay, determine if the solution is rational or irrational. So first we are going to want to simplify the 12 over 2. So negative 3 to the 6th power. So basically we're multiplying negative 3 by itself 6 times, which is 729. And remember, for this, that 2 goes out in front, okay, which is just square root of 5, because remember, if it's a 2, we don't need to write it. And this is like what I was saying with the example before. This is irrational, because even though this is a rational number, this part of it is not. All right, next example. Can the sum of 2 irrational numbers be rational? If yes, give an example. If not, explain why not. So if you're adding two irrational numbers, so in other words, they are numbers underneath the radical that cannot be simplified to integers or something like that. The answer is no, because when you add them, the irrational portion will never eliminate. So for example, if I have, using the last one, root 11 plus root 11, it equals 2 root 11. Okay, that square root of 11 did not go away, so it is still an irrational number. Can the product of 2 irrational numbers be rational? And again, if so, give an example, and if not, explain why not. Yes, because when you multiply 2 irrational numbers, the irrational portion can eliminate. It won't always, but it can. So for example, if we take the square root of 9 times the square root of 9, that gives us the square root of 81, which simplifies to 9. No more radicals, so it is a rational number. So it is possible. Doesn't mean it's going to happen every time, but it is possible. But it didn't say will it every time. It just say can it. And in this case, it can. So, all right. So a little bit of an easier lesson, I feel like, but you definitely need to remember the things from the previous lessons in order to make this one a little bit easier to understand. So if there were parts that were confusing, I suggest going back and either rewatching those videos or asking some questions in class. All right, you guys have a good one. Take